Hello, in this video I will explain exponents for IB. Let's start with basic definition. This is an exponential term and it is read as a to the power of x. In here a is called the base and x is called the power or indices. Exponents are used to represent repetitive multiplications such as this one, 2 times 2 times 2 times 2 is basically written as 2 to the power of 4. This is a lot more efficient than writing the expression like that. Or negative 3 times negative 3 can be written as negative 3 squared. Let's quickly go over the laws of exponents. So this is multiplication. If the bases are the same, a to the power of x times a to the power of I equals a to the power of x plus y. So we add the powers together. Let's write an example. Assume that we want to multiply 2 cubed and 2 to the power of 4. The answer would be 2 to the power of 3 plus 4 and it equals 2 to the power of 7. We can quickly verify this result. We can write 2 cubed as 2 times 2 times 2 and we can write 2 to the power of 4 as 2 times 2 times 2 times and 2. So if you multiply them, as you can see here, we multiply 2 7 times by itself. So we basically can show it as 2 to the power of 7. This is basic verification of the law. Division, a to the power of x divided by a to the power of y equals a to the power of x minus y. Same as multiplication, we have to have the same base. Division can be given in fraction format as well. So again, we will have a to the power of x over a to the power of y equals a to the power of x minus y. So let's look at an example. Assume that we want to divide 3 to the power of 7 by 3 to the power of 4. The result will be 3 to the power of 7 minus 4 and the result is 3 cubed 27. We can verify this result quickly by writing expanding the powers. So if we multiply 3 7 times by itself over 4 times by itself, we can quickly simplify 4 of them like that. So the result is 3 cubed or 27. Addition and subtraction. There is no rule for addition or subtraction, but we can actually collect the like terms. So this is a very common mistake. 2 to the power of x plus 2 to the power of x written as 2 to the power of 2x. Avoid this mistake. We can only collect the like terms because we have 2 to the power of x. We can write 2 times 2 to the power of x. Or we can write another example. Let's say we want to subtract 5 to the power of 7 minus 5 squared. The result is not 5 to the power of 5. Again, this is a common mistake. Don't do that. But we can do actually common factor. And if we use 5 squared as a common factor, in brackets we can write 5 to the power of 5 minus 1. Because if we distribute 5 squared into the brackets, we will have the same expression. So this is equal to 5 squared equals 25. And 5 to the power of 5 minus 1 stays as it is, 5 to the power of 5 minus 1. Power 0 is another law of exponents. Any base to the power of 0 is always 1, but there is an exception. 0 to the power of 0 is undefined. You can check this result with your calculator as well. It is accepted as undefined, but any base with the power 0 equals 1. Let's look at this example. Determine the followings. In here, the base is a big number, but there is power 0, so the result is easily 1. However, this one we need to be careful of because the negative sign is outside of the bracket, so we will leave the negative sign outside, but the bracket itself will be 1 because of the power 0, so the result will be negative 1. Power of a power rule or power to the power rule. It basically says a to the power of x to the power of y equals a to the power of x times y. We don't add them up, we multiply them. And let's look at an example. 2 cubed to the power of squared. The result is not 2 to the power of 5 because 2 cubed is 8, bracket is 8, 8 squared is 64, and it is equal to 2 to the power of 6. Example, simplify the followings. In part A, we will multiply these two expressions. We will multiply constant numbers with each other, so 3 and 9. And then we will multiply terms with the same base, so A and A, B and B, C and C. So it will be 3 times 9 times a to the power 3 to the power of -1. Because it is multiplication, we add the powers together. B to the power of 2 plus 5 and C to the power 1 plus 2 equals 27 times A squared, B to the power of 7, C cubed. We can write the whole expression without any dots, so it will look like this. Part B, we will divide constant terms to each other. Also, we will subtract the powers of the base s. So 12 over 3 times s to the power of 7 minus -1. We have two negatives here, and it will be equal to 4 times s to the power of 7 plus 1, and the result will be 4s to the power of 8. Part C, we have addition of 3r, and it is added 3 times. So again, we need to be careful because we don't add the powers together. We will just collect the like terms, and it will be 3 times 3r, and then times 5 to the power of r and to the power of w. So let's write this down. So 3 times 3r times 5 to the power of r to the power of w. This w belongs each term in the bracket, so 3 to the power of w times 3 to the power of wr and 5 to the power of rw. And because we have the same base here, we can add the powers up. So we have 3 to the power of w plus rw times 5 to the power of rw. In part D, it asks the area of the rectangle. It is length and width are given. So area equals length times width. Length equals 3k squared L cubed times 9k over L. Because we have a fraction here and we know that there is a minus, there is a over 1 here. So we can actually multiply numerators together, 3k squared L cubed 9k over L. And if we multiply the constant terms and the same base terms, k squared and k, we have 27 k cubed L cubed over L, and L cubed and L, it can be simplified as L squared, so result will be 27 k cubed L squared. Powers as fractions or fractional powers. So there is a basic conversion of fractional powers to root symbol. So assume that we have the expression a to the power of x over y. So as you can see, our power is not an integer, it is a fraction. So this fractional power can be written with the root symbol like this. So degree of the root will be denominator of the power, so y goes here, and inside of the root we have a to the power of x, and x is the numerator of the power, and we read this as white root of a to the power of x. Example, simplify the followings. In part A we have cube root of 27. So we can simplify this expression by writing 27 as a power of 3. So we can write cube root of 3 cubed. Now we can convert this into fractional power. So we have 3 to the power of 3 over 3, and our result will be 3. Part B, we have more than one variable in one root symbol. This time we have fourth root of k to the power of 4 times, L to the power of 12 times, m to the power of 24. So we will get out every term from this root symbol by dividing the powers to the degree of the root. So basically we will write k to the power of 4 over 4 because there is power 4 of k, and degree of the root is 4. So we will write k to the power of 4 over 4 as fractional power. Next, L to the power of 12 over 4. And finally, m to the power of 24 over 4. So we can simplify this expression as k to the power of 1, L cubed, and m to the power of 6. Or we can eliminate the dots. We can directly write k L cubed m to the power of 6. Negative powers. Negative powers basically flips the number. So for example, if the expression is a to the power of negative 1, it is written as 1 over a. So it is called also multiplicative inverse or reciprocal. Let's look at some examples. 3 to the power of negative 1 equals actually 1/3. Negative 2 to the power of negative 5 equals, this negative power makes the number flip. So first step is get rid of this negative on the power. It will be 5 and the number will be negative 1 over 2. And this power 5 belongs both to numerator and denominator. So it is equal to negative 1 to the power of 5 over 2 to the power of 5. And it equals negative 1 over 32. If the power was an even number, the result would be positive. But if it is odd number, as in here, the result doesn't change, still negative number. Next, we will talk about exponent equations, meaning we will find the value of the power. This time unknown is the power. Example, solve the following equations. In part A, we have 2 to the power of 2x minus 2 to the power of x plus 1 plus 4 equals 3. So if we move 3 to the left side, we have 4 minus 3 equals 0. And then 2 to the power of 2x minus 2 to the power of x plus 1 equals 0. At this point, it is difficult to solve this question. But if we remove or isolate 2 to the power of x, we may be able to solve the question. So let's say 2 to the power of 2x, write it as 2 to the power of x to the power of 2. And then minus 2 times 2 to the power of x plus 1 equals 0. Now, this question can be solved easier. We will use a parameter for 2 to the power of x. So let's say we will write t wherever we see 2 to the power of x. And this equation becomes t squared minus 2t plus 1 equals 0. Now we can solve this equation. It is actually t minus 1 squared equals 0. And t must be 1. If t is 1, we already said that 2 to the power of x is t. So 2 to the power of x must be 1. And x is 0. Part B. In this question, we are trying to get the same base, and then we can actually equal the powers together, and we will be able to solve the unknown x. So on the left side we have 25, and on the right side we have 1 over 5. If we write 25 as 5 squared, and if we write 1 over 5 as 5 to the power of minus 1, then we will have the same base, and then we can solve the equation. So let's write it down. 5 squared to the power of x minus 1. This is the left side of the equation. And right side we have 5 to the power of minus 1 to the power of 3x. Because we have power to the power situation, we will multiply the powers. On the left side we have 5 to the power of 2x minus 2. And on the right side we have 5 to the power of negative 3x. Now we have the same base. If they are equal to each other, their powers must be the same as well. So let's write it down. 2x minus 2 must be equal to negative 3x. If we solve this equation, 5x equals 2, and then x is found as 2 over 5. Exam type questions. Number 1. Solve the equation below. So we have 7 as power on the left side. We have 1 over 7 on the right side. If we write down 1 over 7 as 7 to the power of negative 1, we can solve the equation. So 7 to the power of x minus 3 equals 7 to the power of negative 1 to the power of x plus 5. And then we will multiply negative 1 with x plus 5 because it is power to the power. So it is negative x, negative 5. Since the bases are the same, powers must be same as well. X minus 3 equals negative x minus 5. 2x equals negative 2, and we find x equals negative 1. These slides are created with part of a digital textbook. Only some of the examples and questions appeared on the video. The book has 9 sections and covers number and algebra unit. The book is created with minimalist design language, easy to follow and easy on your eyes with its dark theme. This is an interactive textbook. Other than written explanations, every section has video tutorials. All you need to do is click on video boxes and start watching. At the end of every section, you will find exam type questions. These questions directly prepare you for IB exam. They have written solutions as well as video solutions. Solutions are prepared in detail to make your understanding easier. You can purchase the book through Apple Bookstore and it works on your iPhone, iPad and Mac. The link is available in the description below. Thank you for your support and I wish you a great success in your IB adventure. See you in the next video.